My second part of the talk I'm going to talk about is my experience in moving data from small to large. Okay, so first I will talk about how we built a platform for doing big data. We used to do this even before the concept of big data was there. Big data, the term big data came into usage only like a couple of years back. But we have been dealing with that type of data even before that. And after that, I will give you 4 different types of usage models of this big data platform and how it is being used. So where did we do it? Just to give you some history here, it started in 1996, 1999, where the first 2 early projects, which we got from the Defense and the USPTO and the National Archives, were involved in that. So the main thing was that the motivation was to do, how do we do data-intensive computation across distributed resources under the administration of different organizations which don't even talk to each other? How are we going to do that? That is what the DOC project was all about, saying that multiple people are doing, generating the data, how are we going to pull them together? And we talked about that. And the National Archives became really interested because the way we were doing things, they felt that that can be used for archival purposes, for long-term purposes, and deal with that type of things. So we came up with 3 different important principles in there. Hide how the data is distributed from the user. Keep everything as a uniform access to that one, and virtualize the resources. When I say virtualize resources, since we are dealing with science data here, remember this is the defense, and they are talking about energy, they are talking about different kinds of sensor data and things like that, and we need to worry about data, scientific data in here. And resources are completely different. They can be in file systems. They can be coming from a sensor network. They can be coming from a tape system. During the olden days, 96, 97, 98, large number of tapes were there, and multiple different types of tape systems. So we had to deal with those type of things, and things were coming from the web. Things were coming from FTP. Things were coming from Gopher sites. We need to deal with those type of things. And we dealt with them by completely hiding, virtualizing everything, and providing with a simple interface for people to look at the data to come up with. And that was done with what is called a storage resource broker data grid. So that is the first time we wrote a paper on what is called a data grid. So pulling things together into a grid. Like we have the power grid. I can bring my laptop, bought in North Carolina, come and plug it in, it still works. I can go to Japan, plug it in, it'll still work, because there is some sort of a uniformity laid into the power grid. You don't know where the power is coming from. It might be coming from a coal plant, it might be coming from a hydroelectric plant, it might be coming from a nuclear power plant. It may not even be generated inside the United States. Probably the power is coming from Canada. We don't even know where it is coming from. We still use it. Things move around, things are done that. And you don't know who is going to use that power being generated. Maybe the Tennessee Valley Authority. But we don't know who it is using it. Maybe today it's going to be people in California, tomorrow it might be people in Maine. Still, it works. The power grid makes it uniform. We want to do the same thing with data grid. People can generate data, put it to the grid, somebody else can use it. You don't know who is going to use it right now. That is where the concept of that came in. We had several follow-up projects for the next 6 or 7 years. One of the main things was the Transcontinental Persistent Archive prototype for the National Archives, also funded partially by the NSF and the National Partnership for Advanced Computing Infrastructure. Here we are dealing with real science data, neurosciences, environmental sciences, marine sciences, seismology, you name it. There were around 7 or 8 different types of scientists data involved in this particular type of project. We built different type of grids. We built a grid for the brain science people, and we built a grid for the biology people. We built a grid for environmental sciences people. We built a grid for the oceanography people. All these type of things. Particle physics. We built one grid for them, for the PPDG. And these were all involved. At this particular level, we had to deal with people. They are not in the same organization. They are coming from multiple places. They want to share, but they want a controlled sharing to do that. And obviously, when you have these type of diversity of science domains being involved, we needed to worry about what type of metadata are going to be there. The neuroscience people have a different kind of metadata. The astronomers had a different kind of metadata. The environmental scientists have different kind of metadata. You probably heard about this. The DICOM schema used by MRIs. Okay, FITS schema for metadata used by astronomers. Right? And the good old librarians, what do we use? Dublin Core, right? In a sense. And what do the environmental science people use? Called Darwin Core. Actually, you can see that they borrowed from the Dublin Core, in a sense. Darwin Core, they use that. So these are different kinds of metadata. You need to worry about how to deal with these type of things. So now we are integrating not just data, you need to integrate metadata, crosswalks. How do you crosswalk from one to another? We know that, how to do that type of things. Virtualize the user, because now the user is completely coming from different places. They don't need to have accounts in different machines, because that's what the real world is. If I want to find data in an FTP server over at San Diego, I either get it as an anonymous person, or I need to have an account on that machine so that I can log onto the machine and get the data out of it. But when you have talking about hundreds of thousands and millions of users, you don't do logins, because it's going to be really, really hard to give 1,000 accounts in a machine. The administrator will come. You know the IT people. They're not going to be very happy about giving 1,000 accounts to people and things like that, who are not even working in the same organization. So we had to deal with those type of things. We had to virtualize it. What we did was we built a third layer of user virtualization where the users get virtualized. So it is like now a global user space. And when we virtualize it, we cannot just virtualize just the user. You need to worry about their authentication and their authorization and their auditing and their accounting. All those type of things needed to be worried about. So when I say virtualize users, it came with a whole bunch of things we need to do that. And obviously, you have to empower sharing and collaboration, and that was the main idea behind the whole thing. And it was a very successful partnership. We had really, at that particular time, we were dealing with hundreds of terabytes of data. We are talking about here early 2000s type of thing. And actually, at one point, one of our in our IT department, during Christmas, when all the normal IT people are not working, we used to have some people, and one guy didn't know what to do when the tapes were running out. They were running out of tapes, and the machine was asking, give me more tapes. So he just said, these tapes seem to be good, and he kept on mounting those tapes. And 2 weeks later, people started coming back from their vacation, Christmas vacation, found their data is gone. Okay, we lost 30 terabytes of data. Like that. At a time, 30 terabytes at that particular time was a lot of it. One of the good things that we are using the SRB, Federated Data Grid, so there were multiple copies of the data. So even though they lost it, we were able to recover that and give it to them. And because of the SRB, there were multiple, these type of anecdotes which came to us in there. They were like in the BERN, which is the Bioinformatics Research Network Grid, which is like around 15 different universities working together. One university's data system was completely down, and people didn't even notice it for like 2 weeks that things were down. Things were not working. They were getting data, still getting data, because the data was going to that thing is down, it automatically reroutes you to another one. The uniform interface takes care of all the interaction of getting the data from there. The user never even worried about it. Then they realized it. Then they shut it down and restarted it, made the changes, and pulled it back up. It worked very well. They came back and said, we had a problem with it, and nobody even noticed it. I said, that is the important thing. That's the way it should be. In a data grid, that happens, right? The power generators go offline, online. Still things work. You need to worry at that particular level. So then, after 2005 to 2013, we did a paradigm shift. What was happening is that we built this data grid, and we're able to federate the data grid across multiple scientific domains, but then people wanted more customizability. How can I change it? I cannot live with the same power thing. I need to use it. I need to customize it. It's not like the power grid, which cannot be customized, which is not customizable, but I would like to change it in a different way. I want my own customizability in there under the context of the whole grid. How can I do that? So we went into a different model and talked with the National Archives and NSF, and we're able to get funding from them to build what is called the Integrated Distributed Processing System. IRODS is the system called Integrated Rule-Oriented Data Systems, where people can customize the data grid to their own needs to do that. So we were allowing people to do processing at the server side where the data is located so that they can customize it. For example, some of the medical science people would like to do anonymization so that privacy and security are maintained on the medical data. And they wanted to do it as soon as the data lands into the system, into the grid, that anonymization should be done automatically. They don't want to rely on a user doing it outside and telling that it is done. You want a workflow which is automated at that particular level. We are able to give that type of thing. And other set of people said that we want to put our data, but we don't want to extract the metadata because it's a very hard process, time-consuming process, and we don't want to do that. So we are able to customize it in such a way that they can do metadata extraction automatically without worrying about how it is done, where it is done. You may have to move the data from one place to another place, do the extraction, and bring it back. All done in a nice framework, in a workflow framework. And that is what we've been working on for until now. And in 2012, we had more than 1,000 projects all over the world using it. Several library projects, the Texas Digital Library, I think from Houston, we have Christy here, and the National Library in France, and one of them I'm going to talk about is the Carolina Digital Library Repository, and the Taiwan National Archives, the Australian system. Actually, I have a small list of that. They've all been using it successfully for several years right now. And currently, we are running what is called a DataNet Federation Consortium at UNC Chapel Hill, which is an NSF-funded project, where we are bringing in 6 different domains and trying to give a lot more than just sharing of data, a lot more of different experiences of doing that in a collaboration. So we are going towards what is called sustainability. How do we sustain beyond the normal way of just putting the data in there and then doing? So that is what is at our stage we are more interested in doing in the future is sustainability of the big data platform and the big data which goes into that. So we built this system called IRODS Distributed Data System. I'm not going to describe it in a sense, but you can say that it provides you with some sort of a virtualized middleware which sits between you as a scientist and the repository where the data is located and tries to broker between you and them in a nice way by putting in multiple types of policies, customizability in there. So if you are a person as a user, you are at a very high level, you see a virtual collection with all the metadata and the services which are underneath it, and this data can come from multiple places and from partners, from yourself, from the disk, from the cloud. All these things can be done without much of a problem. And the central thing basically hides all the idiosyncrasies of the underlying system to do that. And that is where we feel the role of the librarian is going to come in as a mediator, as a person who is going to sit between the user and the repository and trying to be the reference librarian of where to go to get what. As a person, as an organization, how to reorganize the data, how to find multiple ways of retrieval mechanisms so that you can go and get the proper data. The scientists want data. They don't know how to get to that, and how do you deal with it? And this is, again, the role where librarians can play big in there. Just to give you a flavor of what happens in that particular box, in that particular small box in there, is something like this. Okay, at a very high level. We build a collection, we call them collection, So that scientific collections like maybe a brain image collection or an ocean sensor collection and things like that, or a video coming from an instrument in there. People have studied what do you call the embryonic development of zebrafish and put them in there, type of thing. Okay, and then shared it with other people. And these collections have policies. Who can share this collection? What can happen to it? Is this person belonging? Can I give full permission for all the data, or should I give only an abstract of the data to them? What do you mean by an abstraction of the data? What type of process need to be done before I give the data to them? What type of anonymization need to be done? Those are the type of things we are done. And if you look at this particular slide, you will see a lot of keywords in there which have been in the vocabulary of the information and library science. Okay? We talk at the level of integrity, authenticity, right? We talk at the level of consensus and consistency. We talk at the level of persistent state, assessment, periodic assessment, criteria. All those things are in the vocabulary, what we need to do. Workflows are probably not new, but if you are a science librarian, you probably heard the word workflow, because that is where you basically take the data, move it through multiple different types of services and try to get answers out of that. And you can, and this is what is happening. And the way you can customize it is basically by writing more and more of these microservices in there as we want it. We have probably 400, 500 microservices which are pertinent mainly to digital library and digital archives type of thing. And people have written their own specialized microservices for their own domains and share it. We're part of a way of sharing with them, with other people. So to talk about what type of scalability we are looking at, I just picked 5 different projects which are using the IROT system. For example, the National Institute for Nuclear Physics and Plasma Physics, they have like 10 petabytes of data under IROTs. And they're growing. They talk about growing at 2 to 3 petabytes per year. And they are not having only particle physics data. They are being a repository for a lot of other data also, including data from telescopes, data from genomics labs, data from ecosystems, being sensor ecosystems and stuff like that, multiple of them. The Australian Research Collaboration Services has more than 500 nodes where they deposit data. These data is deposited by scientists and they share across them. The iPlan Collaborative here being run out of Arizona, they got more than 15,000 users using it at the same time type of thing. Just to give you a variety of usage. The NASA Center for Climate Simulation, they got 300 million metadata attributes and all being used in this particular system. And CineGrid, basically the AMPAS, the American Motion Pictures Academy, is part of that particular one. They share data across United States and the Americas, the continents, and Asia and Europe for large 4D data. You remember 4K data which is coming up and 4D data which is coming up. They are trying to use our system. I've been successfully using for more than 3 years in doing that. So intercontinental wide, large number of metadata, large number of users, large number of resources, large amount of data which come in. All we have been able to show that this can be scaled very well. We have been scaling up. People talk about billion data files and things like that, and been using it at that particular level. So here are a few of the projects in multiple categories in their international projects, national data grids, institutional repositories which are using it in there. And it is, I think these numbers are a little bit old, projects in 39 countries and 62 academic institutions inside the United States are all using our system. So this platform, we call it the big data platform, provides you with a distributed but uniform way of administering a system and moving across a large user community and providing a sharing across this type of environment. So how did we use this big data platform? I'm going to give you 4. How much time do I have? Okay, I'm going to go fast through this. So I'm going to talk about, mainly I talk about the lifetime library, because that is probably a more important thing, and it's very close to my heart also. So this is a library. This is a project which was started maybe like 3 years back. The dean of the School of Information Library Science came to us and said that, since you have been developing this IROT system, how can we apply it to teach the concepts in library science, in digital libraries, to our own students? And then our thing was, maybe everybody should have their own library. For example, before the digital libraries, when people were using the books, you buy books. And then, unless you are selling it off at the end of the semester, you carry them along and then use them. What do we do with our digital artifacts? You get presentations from your professors. You get homeworks back, digital. You write homeworks, you do exams, and things like that. What do you do with them? You throw them away. How much of your digital artifact, which you had in your bachelor's and master's, which is still with you, you're using it? Not many people do that. They throw it away. Nobody even bothers about it. And even if they keep it, as they move from one system to another system, today I have a PC, tomorrow a laptop, tomorrow I get another laptop, maybe I get a small iPhone, I just throw the laptop away, iPod, iPad, mini-pad, all those things. You move from one platform to another platform, your data gets lost. What do we do so that the librarian students from CILS can still maintain some sort of continuance in there? That's where we did it. We said, okay, we are going to provide each student with 0.5 terabyte of space so that they can start putting all the digital artifacts which they get from their courses and put it in there, and they can keep it forever. That's why it's called a lifetime library. And that was the first one. You create your own library. That is easy. You might say, okay, I just put the files in there. What does it help me? What does it help as a digital librarian? The second one is that we are going to teach them about library, how to handle, how to administer the library by dealing with policies. They can make their own policies of what happens to these artifacts, which they are putting in there, so that they can learn the concepts in library using that. Okay? So we provided them with several microservices, which are library related, which they can use. We provided with different kinds of indexing mechanisms, which they can use for creating metadata for them. And we also held classes. We have a couple of courses basically on lifetime library, which they can take, an introductory level lifetime library course and a hardcore lifetime library course called policy-based data management that they can get their teeth into so that they can learn about the different concepts. And a few of us, our professors, basically do is that as an assignment in class, you have to put things into the library so that by the end of the year, you have some things in there, so that things can be kept beyond that. And students are allowed to build their own collections, and we said that we are not going to restrict to only documents related to your courses. You can put whatever you want in there. This is your library. You can do it. And I can tell you, nobody even exceeded any of the 0.5 gigabytes in there, 0.5 terabyte in there. And our thing is give them 0.5 terabyte, and if somebody hits there and they say, hey, can I get another 0.5 terabyte, we're going to give it to them. But nobody has hit it. Even though we talk about big data, it's not real big data. Okay? So resources are provided by CILS, and we replicate the copies into the Renaissance Computing Institute, where I also work. And policies are student-driven. Each student have their own policies of what to do with it. Who can access the library, their library? Who can federate their library with somebody else's library? They do that. They federate across. them so that they can share things. And what type of, like, simple thing, how many replicas can be there for my library? So they can say, if I say this policy, these 20 or collections will have a replication of 2 copies. This collection will have only one copy, no replication. And this collection is going to be temporary. After 20 days, it goes away. So you can put an expiry date on it, and then it goes away after 20 days or 100 days, whatever you do. So the students are given complete control over their library. They can set policies at multiple levels and do that. And we have found out that students don't do many policies. They don't change many policies. On the average, they change maybe 5 policies on that. Still learning. So the library management, the type of things we do, checksums and versioning, so that you can talk about integrity, different types of integrity of the data, different types of versions, so that they can keep versions of that. If they want, they can turn on the version policy. If they don't want, they can turn off the version policy, so that there is no versions being kept. Strict access controls, they can do that. Nobody looks at my metadata also. Not even the data, but not even metadata. Nobody even can look at my collection. Or they can turn it on completely and then say, everybody can look at everything. They may not be able to access it, but they can find out what I have. So they have a whole bunch of things they can do. They can talk, we talk about quotas, how much of things they can put in there, and metadata catalog replication, if they want the metadata to be replicated or not, and things like that. And we have services for them to do ingestion and automated loading and extraction and things like that. The type of files which people put in, here we talk about only their main collection. What is the largest collection a student has? And I'm picking up a representative set of students in there, and then they looked at what type of things. iTunes is a very, very, very popular thing. Photos, music. This particular student was taking a was a music minor or something like that. She had a lot of music in there, so she put them in there. So you can see that, not much in there. 50 gigabytes, not 500 gigabytes. 50 gigabytes is the maximum or something like that they had. But then when you're loading 50 gigabytes, that is where the problem comes in. When you're trying to tag them together, how to deal with it and things like that is where the problem. We use AVUs called attribute value units. So that is the concept we have for our metadata. You can have a schema on top of it. So you can talk about a Dublin core schema or anything like that. Or in the case of Flickr, Flickr has its own metadata schema. You can export that metadata from Flickr into this one without any problem. Same thing with iTunes. iTunes has its own metadata. They can export from there into their digital library, so that anything happens to their iTunes, they don't need to worry about it. They can still keep a copy. The only thing we tell that, don't keep things which you don't own. And don't do something bad your mom doesn't want to know about. And they've been really good. Okay, the other, like I said, I'm going to talk about several other things. So that one, in a sense, if you look at it, is a personal digital library. But the same IROT system has been used as an institutional repository by the Carolina Digital Repository. And then we are doing the National Federation across multiple disciplines based mainly on policies type of thing. And finally, this is the main project which I'm now dealing with, is called the DataBridge, where we are looking at data communities. So I'm going to skip a whole bunch of things and go to the DataBridge. Sorry about that. Oh, I should do this one. These are the type of policies we are trying to do for our DataNet Federation Consortium in there. You can see the type of policies in there. If you read the words, a lot of them make sense. There's nothing new in the vocabulary which we are putting in there. But how we deal with it and things like that are the main. Replication and synchronization. Okay, domain-centric policies, publication, IPR and citations, archiving, caching, authentication, authorization. All these things are common vocabulary terms shared by LSIS in there. So the data bridge is basically, can we make data a citizen? We are citizens. We have our own Facebook. We have our own iTunes catalog. We have our own Flickr photograph collection, right? Video collection, YouTube. Yes? What does the data have? Nothing. Right now, data is passive. So the data bridge is a vision where we want data to be a citizen so that it can be live, it can have its own Facebook, we call it data book, obviously, because data don't have face. They can have their own data book, and in the data book, they can have friends. How do they do friends? Similar things. Okay? This data is similar to another data. So there are type of way of doing similarities between them and how similar they are. They can form communities because they share certain things. They share methodologies. For example, if I'm going to use the same statistical process on this data and I use the same statistical process on other data, they share the same methods. They share the same user. Maybe all of them originated from the same place. They all came from the same instrument. They are all astronomy data. You can see that data can be a citizen and have friends, have properties, and can obviously even they can also unfriend hopefully at one point. So that is what we are doing in this case. We are dealing with what is called long tail of science data. We are not looking at data which is being generated by these large systems. We are not looking at NASA data. We are not looking at data coming from the NOAA climate people, not data coming from the Large Hadron Collider. They have people who deal with them very well. We are talking about scientists, individual scientists, small groups who don't share data that much because there is no facility for them to share their data, which is residing in their own desktop or laptop or their servers, don't find other data. We want them to find other data to do that. Enormous amount of data distributed and unconnected. They are called dark data because they're not even available for people to use. There are multiple formats. Each individual scientist will have their own idiosyncratic way of putting things together. Some of them are good in metadata, some of them are no metadata, gathered by one or more scientists, not shareable, not discoverable, and you need to worry about how can I make sure that this particular data is visible to a lot of people. So what we did is that the same type of things which Facebook uses, the same type of analysis which eBay or Amazon.com tries to tell you what reference you have. For example, if you go to Amazon.com and try to buy something, it also tells it, when you are looking at this, the people who bought these things also looked at other things. They bought these things together because they are trying to tell you that there are a wider variety of things to do. And you can look at, they give you suggestions, like a reference librarian. That's what Amazon.com does. And we want to do the same thing. And our idea is that can we use the type of analysis these people do to data and get the same type of thing. Sociometric analysis is the keyword in the DataBridge. We do the same type of sociometric analysis which are being done by Facebook or Twitter or Amazon.com or eBay or Google and try to figure out how one data is related to another data. And there are 3 tasks and challenges we need to do. How to evaluate similarities. How to find friends, basically. How do we find relevancy between data sets? Perform community detection. Once you know how similar they are, what type of communities can be formed? And you can see that multidimensional communities can be formed at different layers. And that is where the thing comes in. It is a very exciting field because you don't know which new community is going to pop up tomorrow. And having said that, how are we going to make it available so that people can use it? How can people become part of this community? How people can access this community? So again, it's a social network of data. You can look at each one of those things and think of them as people on the Facebook, or you can think of data which is created by people. And then here is an example. This is a real example, actually. One of our undergrad students took a bunch of data and tried to pull them together and then showed that how we can relate them together. The thicker the line, are you able to see the lines there? I'm not able to. Ooh, sorry, the lines are not. The thicker the line, better they are related. The thinner the lines, they're not related that much, type of thing. So it basically says that there is a very thin line between the survey. This is survey articles coming out of the Odom Institute. So we looked at multiple surveys and then pull them together and say, okay, take these 20 surveys and try to form a community out of them. So that's what it is, type of thing. Basic similarity, people who are Facebook friends with me, and you don't have any other information, you need to try to deal with that same type of things in the case of DataBridge also. So, and here again at a very high level view of how we are building this social network, we try to figure out between data, what type of connections are there, between the usage and the data, between the methods which are applied and the data, and things like that, and try to figure out multiple dimensions of that. And these are the type of sociometric analysis which we do for trying to do that. And you can see some of them are something which you probably know about. PCA, right? The principal component analysis is a bread and butter of information retrieval. Latent semantic analysis type of thing. Digital signature analysis is coming up now, but things still are far away. They currently do it at a version by version level type of thing, but not really between two disparate data. And we would like to extend that beyond that type of thing. So what we did was build a very flexible platform based on the IROT system so that people can add their own way of finding similarities. So again, in our case, we are not going to tell you how to find similarities between your data and their data. You are a scientist. You are coming from some esoteric, you worry about data about, say, newts, okay, on tadpoles and newts and salamanders and things like that. And you can tell me, how do I find similar data? We can write a routine based on that and put that into our relevance algorithm so that the relevance engine can take your method and go across all the data to find other data which deal with salamanders and newts and tadpoles and things like that. Okay? So we are not going to write routines which are catch-all for everybody. Everybody writes small things, they become part of it, and they get analyzed. And so it is a highly extensible big data. That's what it is. One of the things about big data is that you don't do things in one place. You do it in multiple places. And this is where we are coming in. And you can see that we get data from multiple places and reformat it and things like that and keep on adding things to that. The future of big data platforms, how are we dealing with it? Again, the biggest one which are coming up is genomics. We are already working with it. For example, the IROT system is used by the Sanger Institute and the Broad Institute here. Uses the IROT platform for a lot of their genome data storage and retrieval and metadata extraction and things like that. And we are building what is called an end-to-end clinical genomic informatics system at the Renaissance Computing Labs. Multiple things are happening in there, and people are not even thinking about how to store these things. It can cost $75 billion in disk space alone to store some of the things in there. So do you want to store all of them? How do we make relevancy? This is again a librarian type of thing can look at value of what is the value of the data and then which we can store and which we can throw away and so on and so forth. Okay, I think I'm going to stop at one point here somewhere and talk about, I talked about the challenges of big data and how the role of librarians weaves together as in a sense, a constant in the whole thing from small data to big data. And I talked about a couple of projects which used the big data at UNC, and it spans across not only at UNC, but multiple universities and multiple institutions and multiple countries and continents. Looking towards the future, the main thing is that data cannot live alone. It has to integrate with computing and networks, and we are trying to deal with that one. Like the DataBridge project is basically, you can talk about as a network of data. And how are we going to make sure that they work together, talk together, and live together? And that is my conclusion. Thank you very much.